Hi everyone, welcome to Pre-Calculus Lesson 6.6. This is the law of cosines. Now this is the second law that we have to use on triangles that are not right. So this is using, obviously, cosine in a formula to find missing measurements in a triangle that is not right. So here is the law. And you'll always find it written as three separate values. Now, I don't like to use all three of these. The thing to remember is that the side length that is here needs to be across from the angle measure you're referencing here. That's the important thing to remember. So what I'm going to do is I'm going to cover up the two expressions that I don't want right now. We're just going to focus on that first one. Now remember, angle A is across from side A, angle B is across from side B, and angle C is across from side C. So if I want to know either side A or angle A, then I'm going to use this version of the formula. Because if you have an x here, you could solve for that x. If you have an x here, you could solve for that. You cannot have unknowns in here for these other two sides. They're not allowed to be unknowns. Not allowed at all. Okay, so if you remember that, then all you have to do is you take the side that's across from the angle in question. Maybe you know this angle measurement, but not this side, and that's okay. But you take the side that's across from the angle, and that gets squared, and it equals the other two sides squared and added together. And that's almost like the Pythagorean theorem. Do you see it hiding in there? A squared equals b squared plus c squared. It's almost like the Pythagorean theorem. And then it's minus 2bc, so 2 times each of those side lengths times the cosine of A. So these b and c come right here, bc, times the cosine of A. Now you'll notice that in these other two formulas, all they did is they switched out the a's and the b's. So here are the a's, they switched them with b's, and all of the b's became a's. And remember, it doesn't matter how you labeled your triangle as long as side B is across from angle B. So I just remember one of these, and then I just fill in whatever information I have. So if they gave me angle B, I would do b squared equals a squared plus c squared minus 2ac times the cosine of B. Okay, so once you know one of these, and you just remember that this is the side across from this angle, you don't necessarily need to label the A's, B's, and C's as they are in the picture. Okay, it's just this side is across from the angle. Let's see some examples, and hopefully it'll become more clear. In example 1, it says, a tunnel is to be built through a mountain. To estimate the length of the tunnel, a surveyor makes the measurements shown. Use the surveyor's data to approximate the length of the tunnel. So notice we have this angle. This is the side in question. This is going to be X, or A if you prefer. And then we have these other two sides. So try and put them into the law of cosines formula, and then try to solve for C. So pause the video to do that, and then press play to see if you did it correctly. Okay, so I said this side is squared equals 388 squared plus 212 squared minus 2 times 388 times 212 times the cosine of 82.4. Now to solve for our missing measurement, I would just need to do the square root on both sides. So in my calculator, I literally just typed this in. This entire thing just got typed into my calculator. I find out that C is approximately 416.8 feet. Now, it's not going to come out exact because cosines generally give us irrational values. Same thing with square roots. So it's not going to be exact, but that is the rounded value for this. And they should give you rounding directions. Otherwise, you can round to the tenths or hundredths place if they don't. Let's take a look at another example. In example 2, it says the sides of a triangle are A equals 5, B equals 8, and C equals 12. Find the angles of the triangle. So what you're going to do is you're going to try to draw this triangle, and then you're going to use the law of cosines to find each angle. So start out with angle A. Draw the triangle, find angle A, and then press play to check your answers before you go on to B and C. So for angle A, I put in, here's A. So I did 5 squared equals 8 squared plus 12 squared minus 2 times 8 times 12 times the cosine of A. Now to solve for this A here, you would have to do 5 squared minus 8 squared minus 12 squared and get an answer for that. Then you have to divide by negative, be careful, negative 2 times 8 times 12. And you'd want to multiply this separately and find out what that is first. Then finally, you do the inverse cosine for angle A. Okay, we're going to try it again. This time, find angle C. I know I'm going out of order, but I'll write out the steps for angle C, I promise. Okay, angle C is across from the 12. So I'm going to do 12 squared equals 8 squared plus 5 squared minus 2 times 8 times 5 times the cosine of C. Now, C comes out to be 133 degrees, and we would do 12 squared minus 8 squared minus 5 squared to get 55. Then I would do 55 divided by, now 2 times 8 times 5 is 80, so divided by negative 80. And then I have to do the inverse cosine. C is the inverse cosine of 55 over negative 80. And that comes out to be 133 degrees. Now at this point, yes, you could use the triangle sum theorem, do 133 plus 18, then subtract from 180. But just remember, if either of these two measurements is wrong, you will get a wrong answer for angle B. However, if you use the law of cosines a third time, it's not going to depend on any of the measures that you found. So it could be right when you would have been wrong if you got one of these two wrong. So find out the value for angle B and then press play to check your answer. My formula was 8 squared equals 5 squared plus 12 squared minus 2 times 12 times 5 times the cosine of B. I found out that angle B is 29 degrees. Okay, let's take a look at one more example where we have to find measurements using the law of cosines. Okay, it says to solve triangle ABC, where angle A is 46.5 degrees, side B is 10.5, and side C is 18. So start by drawing the triangle, solve for side A, and then solve for the other two angles. So pause the video, do that, and then press play to check your answers. So my triangle looked like this. Angle A was 46.5, and that's across from side A. Side C is 18, and that's across from angle C. And side B is 10.5, and that's across from angle B. Now, the only thing we can solve for first is side A. That's what we have enough information for. We can't solve for anything else, so that's where we're going first. So A squared equals 10.5 squared plus 18 squared minus 2 times 10.5 times 18 times the cosine of 46.5. To solve for A, I just did a square root on both sides and typed it all into my calculator. I got 13.2. Now for angle C and angle B, once I know that this is 13.2, I have to use it. There's no choice. So I found angle B first. So I did 10.5 squared equals 13.2 squared plus 18.2 squared minus 2 times 13.2 times 18 times the cosine of B. Then I went through the same steps. I subtracted these from this. I divided by the whole thing of negative 2 times 13.2 times 18. Yes, it is negative. Watch that minus sign. And then I did the inverse cosine of that result, and I got 35.3. Now you can see my calculations for angle C. I got 98.2. This was the formula. And that's it for this example. So if you have any questions about using the law of cosines, make sure you write them down. But now we have another example where we need to find the area of a triangle, but they haven't given us what they normally give us for area of a triangle. This is the last thing for our lesson, I promise. Okay, Heron's formula is that the area equals the square root of the semi-perimeter times the semi-perimeter minus side A times the semi-perimeter minus side B times the semi-perimeter minus side C. Okay, so S is the semi-perimeter, which is half the perimeter. So you would add up all the side lengths and then divide by 2. Okay, so that's what all of those S's mean. So this is the semi-perimeter, 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 and semi-perimeter, and these are all of the side lengths of the triangle A, B, and C. Our last example is example 5. Yes, I know we skipped example 4. That is heading and bearing and using navigation to find missing measurements, but we're not going to do that. We're just going to focus on finding the area of a triangle. So a businessman wishes to buy a triangular lot in a busy downtown location. The lot frontages on the 3 adjacent streets are 125, 280, and 315 feet. They want us to find the area of the lot. Now, the beautiful thing about Heron's formula is that you don't need the height of the triangle, which is often more difficult to find. So what you're going to do is first find the semi-perimeter of this lot that they have. So remember, you add them and divide by 2. Then take that number and put it into Heron's formula with these 3 side lengths and see if you can find the area. So pause the video and do that, and then press play to check your answer. So the semi-perimeter is 360 because you add these together and divide by 2. That comes out to 360. And this is what it would look like if I put it in. Now, a lot of times, instead of having all these parentheses, I like to actually do 360 minus 125 separately, and do this one separately, and do this one separately. But it's up to you if you want to put it all in at once. So the area comes out to be approximately 17,452 feet squared. That's the answer for this question. We're completely done. So that's it for this lesson. Please make sure that if you have any questions, you write them down and let me know what they are.